Another way to solve a quadratic inequality is to graph it and then see where the solutions would be to shade once you shade your graph. So you'll have to graph it first though. So if we try to graph the inequality 1/2 x squared plus 3x minus 2 is less than 0, we would need to find our vertex. So x will equal negative our b value over 2 times our a, which is 1/2. So negative 3, 2 times 1/2 is 1. So negative 3 over 1 is just negative 3. That's our vertex. Or x value over vertex, I'm sorry. And then we need to plug y back in. So 1/2 times negative 3 squared will be 9. Plus 3 times negative 3 is minus 9 minus 2. So negative 9 and negative 2 is negative 11. Negative 11 plus 4.5 is negative 6.5. So the vertex is going to be negative 3, negative 6.5. Now solutions to a quadratic equation are your zeros, your roots, your x-intercepts. So we need to do similarly the same thing here. We need to find where the x-intercepts would be if we were graphing this and trying to shade it. So we found our vertex, and you guys could plot that if you wanted. Negative 3, negative 6.5. But we want to find our x-intercepts, and it's in intercept form and it's factored. So I'm going to try to factor this. 1/2 x squared plus 3x minus 2. So I'm actually going to factor out that 1/2 because I don't want to try to factor something with a leading coefficient of 1/2. So if we divide out 1/2, when you're dividing by 2, or dividing by 1/2, it's really like multiplying by 2. So the 1/2 x squared is just x squared, but 3x will now be 6x, and minus 2 will now be minus 4. Dividing by 1/2 is really just multiplying by 2. If you start with one thing and you cut it in half, you now have two things. 1 times 2 is 2. So can we factor what we have left here? And unfortunately, we can't. So we always do want to check because I always think factoring is a lot easier if you can do it than using the quadratic formula. But I'm just going to use the quadratic formula to get our two values. So we're going to do the quadratic formula for just the part inside the parentheses. So x will equal negative 6 plus or minus 6 squared minus 4 times 1 times negative 4 all over 2 times 1. So if you guys simplify that, we get negative 6 plus or minus 36 plus 16. So 52. Over 2. So what I'm going to do is get the decimal values there because I want to plot these on my graph. So when I do negative 6 plus the square root of 52 divided by 2, I get 0.60. So if that's an x-intercept, I'm going to make it an ordered pair. So let's see, we've got the vertex. We've got one x-intercept. And then when I do negative 6 minus the square root of 52 divided by 2, I get negative 6.6. I'm going to make that an ordered pair. Those are my two x-intercepts. So let's graph those. So positive 0.6, so kind of in the middle. And then negative 6.6. And I should probably try to make it come off of the graph. There we go. Okay, so are less than 0. So if you guys were to make that 0 y, which is what would normally be there, we would normally see it written as y, and we're going to flip it this way because the open or greater side is facing y. So it's really saying y is greater than your equation or your inequality, your quadratic there, x squared plus 3x minus 2. So if it's y is greater than, if you make that 0y, we want to shade within our parabola there. So our solutions for our x values are from here to here. So what did we just say those x-intercepts were? We're just going to write the solution in interval notation. And what did I forget to do? My line for my graph should not be solid. It should be dashed. So let's fix that, because that will change our interval notation. Okay, so still from the same values, but they're going to be parentheses since our boundary line for our parabola is not including any solutions. So from negative 6.6 to positive 0.6 would be our solution for this quadratic inequality. Any x value you choose in between those two values should work for that inequality and make it less than 0. The final way solving it algebraically without the number line and without the graph is the way you guys will probably see it done or need to be able to do it. But this table and this graph are two ways of possibly solving a quadratic inequality.